in space between things. So spatial analysis is really a way of answering spatial questions, solving spatial problems. So when we analyze geographic information, when we look at things like maps, our brains really automatically start doing spatial analysis themselves. So when we view, say, this map in the upper left corner here, these are pirate attacks in and around Africa and the Middle East. So we first, our brain tries to identify patterns in these attacks, just all on its own. Here are pirate attacks all around the world in our lower image, right? So our brain is automatically saying, well, look at this huge cluster here on the eastern coast of Africa or in Oceania, northwest of Australia, right here, these huge clusters. So our brain is performing spatial analysis without us realizing it. Spatial analysis is a way of formalizing what we tend to do when we look at geographic information already. So spatial analysis is the process of looking at the locations of things, analyzing the relationships between locations and attributes over space. And so we do this in a number of ways through overlay or other techniques. And the key here is we're trying to answer some question or gain some new knowledge. So when we perform spatial analysis, we're either going to create new information, say output a new data set as part of it, or we're going to extract some information from an existing data set. But really, spatial analysis comes down to answering questions and solving problems. So here's just a very short list of what a spatial question might look like, right? What is inside a neighborhood, or what are all the different features within some boundary? What is near a treatment plant? You could also ask, how far away are things from that? Where are there concentrations of, say, a pollutant in the water or in the air? How do those concentrations vary over space? Are there spikes in the locations of particular crimes over time? So tracking diseases and the spread of pathogens, this is a spatial question. What is a suitable location for a new cell phone tower, right? Where do we want to locate that? These are all different problems you might want to answer and do so in a GIS environment. What we're going to focus on today are analysis tools that live within a couple of different categories. The first one are extraction tools. So these are things that identify what is a subset of some data or a geographic subset. So we'll look at tools for clipping features, sort of like a cookie cutter, or also a spatial query. Overlay tools are those that look at relationships in overlapping features, right? So if you imagine our GIS layers are a stack of maps, it's like looking down through a stack of maps to identify what's on top of what. And so we'll use intersection and union tools. We'll also look at some proximity tools. How do we quantify how near or far features are from one another? Buffering identifies regions within some distance of a feature. And we'll also use the near tool or the point distance tool to quantify distances between our data. The workflow we work that frames what we do here in spatial analysis is first we need to frame the question. We need to determine what is the scope of it, break it down into its component parts. And then the really tough part in any spatial analysis workflow or any project is finding the data and exploring those data. Is it appropriate to answer your question? Is the resolution or the scale of the data appropriate, both spatially or temporally? How accurate is it? Is it in the right format? To answer our question, we'll choose a method, and generally we want to look into common approaches or review the literature for how people have solved these problems in the past. We perform the analysis using, we'll go into the ArcToolbox a little bit today, but there are also more sophisticated tools available to you, such as a model builder, which links a series of processing steps, or Python. You can write a script that will link a sequence of processing steps. And then you want to examine the results visually, but oftentimes statistically is very important. So in a couple of weeks, we'll look into how do you analyze the statistics of spatial data. When you perform spatial analysis, you'll often see this term spatial geoprocessing, or it's referred to as geoprocessing. This is using all sorts of tools available to you in a GIS to answer these spatial problems. So generally, we're going to incorporate one or more data sets to answer our question, and we're often connecting several tools together in a sequence. So this framework together of applying multiple data sets to answer a question and then processing those to determine some property of them, combined into a new output, this framework is called geoprocessing. What's the example shown here, we're going to analyze some elevation data set, some soil data set, and a vegetation data set together. And each one of these components has some calculation run on them. So a processing tool called slope, a processing tool called aspect, would both be run on elevation and result in these intermediate outputs. Then we also make a selection from our soil and vegetation. And here we have 4 new output data sets. We might run another union tool on them, and we have a final result that answers our question. What's important to note here is that the order in which you apply these operations will have a huge impact on your output and whether your results are valid. But geoprocessing is this term you'll see come up when you read about spatial analysis. In ArcGIS, our spatial analysis tools are mostly available through ArcToolbox. So on our first workshop, we learned that this is a component of the ArcGIS desktop software that kind of hides in the background. It's always there and available to you in ArcCatalog or ArcMap. But this has sets of geoprocessing tools that have a common functionality or purpose or theme. There are also extensions, which are add-ons to the software that enable additional functionality. So through the ArcToolbox, we're going to have access to all of our spatial analysis functions. Extensions are, we have a lot of licenses for extensions here at Clemson, the spatial analyst, geostatistical analyst, and others are ones that are really commonly used. These are add-ons to the software that they come built in, but you have to actually check a box to enable them for them to work. We'll use a lot of the spatial analyst tools in the next workshop on intermediate spatial analysis. A tip I'll give you when you really start performing lots of analyses on your own is the search window. You can access this by hitting Control and F on the keyboard, and you can search for tools, because oftentimes I can't even remember where in the ArcToolbox a particular thing lives. So the find or search tool is really useful. Questions so far? Pause for a second, drink some water. Okay. So this first set of tools we're going to look at are extraction tools. So again, these are going to find some subset in your data. So they're either going to select a portion of your data. So we did tabular queries where we selected features based on their attributes. We can perform spatial queries that use location of features to select a portion of your data set. We can clip your data, much like a cookie cutter would work. We can cut out portions of your data set to isolate those features. And we can also split data into multiple data sets. say along some attribute. So here we might want to split out our data on attributes or geographically. The first one of these tools we're going to look at is the clip tool. And this uses features in one data set to cut out another one. So I've said it a couple times now, this is going to be like a cookie cutter for your data. So it retains anything that overlaps between two data sets. It will not change any of the attribute information in your data. All it's going to do is change the geography. So you don't lose any attributes when you perform this operation. This will work on any type of geometry. You can cut out points, lines, or polygons, but you need to have a polygon boundary that defines your clip area. So we commonly use this if you have a very large data set and you want to restrict it to one particular area of interest. So let's say we get highways for all of the United States, but we're only interested in South Carolina. We don't want to wait for it to load every time we move our mouse around in ArcGIS. We can clip out a portion of the data set. So graphically down here at the bottom, the way this would work is if we had these points W, X, Y, Z, and our clip area is our circle, after we perform the clip, we'll have just points 1 and 2 because they overlap our circle here. And the attributes that would be retained are all the attributes are retained. That W and Y would be in the output data set. Does that make sense? Cookie cutter, clip. So another example here would be we have contour lines for some area. I believe this is Philadelphia or somewhere along the Schuylkill River in Pennsylvania. And if you're only interested in, say, those contour lines here in the business district of town, our business district becomes the cutter and the contour lines are our dough. Right? Here's our cookie dough. We're going to clip out just that portion. So what we're going to do will, oops, looks like I have a typo here. We're going to look at a variety of data for South Carolina. We're going to look at some highways and clip those to South Carolina using the clip tool. So it looks like I have a typo here where it says streams and watershed. I should say highways and clip boundary. So let's get started then. We'll open our software. We're going to start with ArcCatalog. We can also see where our data live. I'm going to open the Windows Explorer here, that folder icon. So for those here in the lab, the data, like normal, are already on that D-Data2 drive, that hard drive of these computers. So I'll click on D-Data2, and there's the basic spatial analysis folder. And here we have, you can see a few different geodatabases that show up as folders. In Windows Explorer, we have our tutorial and presentation as well. So we're going to connect to that D basic spatial analysis folder in ArcGIS. So now I'll open ArcCatalog. I go into my All Programs, to ArcGIS, and open ArcCatalog 10.5.1. So for those of you remotely, your pathway to the data will be different than ours. You'll connect to the folder where you've extracted tutorial data. So I have ArcCatalog open. Is everybody there? Good? All right, I want to connect to that location. Where do I need to go? Where do I need to go in my software to connect to a folder? Connect to folder icon. What does it look like, John? It looks like a folder with a plus sign. Yep. So hopefully by this point, we can all remember that connect to folder is the folder with a plus sign. So I'll navigate in my computer, go to data to D drive and click on that. Click basic spatial analysis, and that will be my path down here, and I'll connect. Click OK. So go ahead and expand that folder. And let's preview our data a bit. So how many soup cans are in that folder? How many geodatabases are we looking at? 3 of them. Yep, so we have our basic spatial analysis.gdb geodatabase. I'll expand that. What kind of data do you see in here? Vector or raster? Both? None? Vector. All right, so we have vector data. How did you know? You see the icon, my chocolate chip cookies, my pizzas for polygons, and my spaghetti for lines. Yep. So let's expand that results geodatabase. Anything in it? Nope. So here I've created an empty geodatabase. We're going to store the output of our operations here. And then there's also this spatial analysis problem geodatabase. So at the end, you'll see I've given you a bit of homework. All the data you need are in there. But you can click the preview tab, take a look at some of the data available. So we have airports, bridges, Charleston County, counties in South Carolina, groceries, highways, hurricane shelters, schools, storm surge zones. So lots of different data. What do we want to look for in our data? What do we probably want to know before we dive in and do any analysis? What did we talk about for half an hour or more in the second workshop? Talked about it during data creation. What do we want to explore and find out about our data before we do any analysis here? The coordinate system, right? We want to look and see what coordinate systems our data are in. Our area of interest for today is just going to be South Carolina. So I would prefer to use the South Carolina State Plane Coordinate System. Because again, these state plane coordinate systems are very, very good for representing specific states or portions of states with minimal distortion across all those properties. So where do I want to go to look and see what coordinate systems my data are in? Properties, how do we get there? Right click on one of those feature classes over here in my catalog tree. So I'll right click my airports, click on properties, go to my XY coordinate system tab. And what coordinate system do we have for that one? South Carolina State Plane, what are the linear units on that particular? Meters, yep, so it says down here, linear unit meter. And all right, so go ahead and inspect the coordinate systems for all these different feature classes. And as you find them, just holler out what you see. I'll open my bridges. I see they're also in South Carolina State Plane. I'll let you all look, and if you see a different one in use, tell us which one and which data set it is. Highways US feature class. Which coordinate system is in use? WGS 1984. Is that geographic or projected? It's a geographic coordinate system. Yep. So I see it has an angular unit of degrees, not a linear unit. And it also has those letters GCS in front. Right. So it's a geographic coordinate system. Any other data sets not in South Carolina State Plain? Or is it just that one? And I'm only interested in the basic spatial analysis geodatabase, right? Anybody find any others? Nope. All right. So it's just that one. So we want to project that data set into our state plane coordinate system. So we're going to use the project geoprocessing tool to do that. So go ahead and hit Control and F on your keyboard, or you can click this button near the top middle of the window and open the search dialog. And it should open up on the right side of your screen here. And then just type in the word project to search. Yep. Oh, to open the search window, you can hit Control F on the keyboard, or there's this button, the search at the top. Yep. And then we're going to type project and search for that. So the tool we want is this. It's the second thing in our list, the project data management tool. It projects spatial data from one coordinate system to another. Something I see a lot of people mistakenly use is the define projection tool a couple down from it. That's used to set the coordinate system for a data if it isn't already listed. Sometimes you'll open a data set and try to view the coordinate system and it will say unknown. So you may have to do some detective work to figure out which coordinate system is actually in use, but you would use define projection to set it if it's not already set. The project tool is one you use to convert from one coordinate system to another. And that's the one you'll want 95% of the time. So let's click on that tool. Here in our list, you can just click on its name and it should open for us. I'll drag my window here. A really useful thing is if you click on this show help button here on the right, this will show you oftentimes what that tool will do. Say convert between these two coordinate systems. And as you click around, it will give you more information about each parameter of that tool. So what we need to specify is our data set and the coordinate system we want to output. So for my input data set or feature class, I'll click the browse icon at the end. Go to my folder connections at the top where it says look in. Go to my basic spatial analysis folder connection. Double click my basic spatial analysis geodatabase to enter into it. And then I want to click on that Highways US feature class and then click add. The output, I'll also click on the browse icon just so we get practice navigating here. I'll look in my folder connections, go to my basic spatial analysis folder, my basic spatial analysis geodatabase, double click to go into it. And we'll give it the name highways_US_PRJ to indicate it's going to be projected. So then I can hit save. And we want to specify our output coordinate system. So I'll click this icon here at the end of that bar and go to my projected coordinate systems folder, expand the state plane folder. And I'm going to use this third one from the top, NAD 1983-2011 meters. Expand that, and I will scroll down this list till I find the South Carolina state plane system. So again, I started in projected coordinate systems, expanded the state plane folder, the NAD 1983 2011 meters folder, and scroll down until I find South Carolina. Click OK. I'll look through my tool. I don't see anything else required to run it. I can click OK. And there are a lot of features in that data set, so it may take a minute or so to run. Yep. Project on the fly is for visualization. We're going to perform analysis. We're going to measure distances in our data. So we want them all to be otherwise.
This is just my general question. Do you think you can briefly explain the difference between projected and geographic coordinate systems? Why you choose like which?
I'm going to grab my prop. So, just a review of our coordinate systems again. So, to review, geographic coordinate systems are a three-dimensional coordinate system that's going to plot your location somewhere on a 3D representation of the Earth, like a globe. And so its units are angular because it's giving you an angle from the center of that spherical model to the equator or the prime meridian, and then to your location on the Earth. So using my arms, here's the equator, and if I'm measuring an angle to South Carolina, it's going to be something like 34 degrees. And then I combine that with my longitude together, so these two angles define a position on that 3D surface. So our units of distance are angles. And that angle, or that it does not span the same distance uniformly across the Earth. So down here at the equator, 10 degrees of longitude is like this, and that distance shrinks until it becomes 0 at the poles. So it's a projected coordinate system was where we are, in the old days, physically projecting a three-dimensional surface onto a two-dimensional plane. Now it's all mathematical transformations, but the idea is the same. If I were to trace this boundary onto the projection, now I have a flat surface to work on. And that system is Cartesian. It's flat, has axes at right angles, and it can be measured in meaningful units like feet or meters. So along with every projection was the distortion of some sort, so we had to choose an appropriate projection. For the data today, we'll use that South Carolina state plane system because it minimizes distortion for South Carolina. Great. I had another question about when is it acceptable to project on the fly? I would say if you're just visualizing data, but if we're going to perform any sort of analysis like we'll do today, we definitely want our data to be projected into the same coordinate system. Because we'll be measuring distances quite a lot, and so we want to choose an appropriate projection where the distance property is preserved. So if you click between the Highways US layer and the Highways US projected layer, Notice when you preview them, they look totally, well, not totally different, but visually, we're looking at data in two different coordinate systems. Any other questions? Good. All right. So let's open ArcMap then. From Arc Catalog here in my Basic Spatial Analysis folder connection, I can double click on this Basic Spatial Analysis tutorial.mxd. So if I double click it, it should open ArcMap for me. If you've made changes to it, you might want to reopen it. When it opens, you should see something a little bit different than we're used to. There are 4 somethings in our map document. What are there 4 of? What are there 4? Did everybody sign in today? All right, I get my business analyst desktop message center. I can close that. If you get a notification about hardware acceleration, remember to click no. On these machines, it will cause it to crash over and over again. Here is my map document. So here we see we're looking at South Carolina, a lot going on in the map. Looks like we have some highways, lots of other stuff. But there are 4 things in this map document that's a bit new. What are they?
Data frames.
Data frames. How did you know, Storm? So here in the table of contents, we have our craft single slices, our cheese over here that indicates a data frame. So there are these 4 different data frames, each with a different name. And we'll work through these here. But remember, we can have multiple data frames in a map document. Each one we can add data to and work with separately. So the data frame is, it's both this central part of the software, this window where you construct a map, and they're also a group of layers that operate somewhat independently from one another. So you can have multiple data frames. For instance, when we set up a layout, you could have multiple maps together on a page. So we're in the extraction data frame. We see there's also overlay, proximity, and spatial join. But here we are in our extraction data frame. So we see some data in here. Our reference layer is part of our base map. We have hurricane shelters, groceries. We have some highway data, the South Carolina border, and an oceans base map. Let's add that projected data set, that Highways US projected data set to our map. You have our Highways US layer, which if I open those layer properties and go to the source tab, I can learn about the data. And here I see that's in those geographic coordinates. I want to use my projected data set from here on out. So I'll click OK, close my layer properties, but go over to my Arc catalog panel here, expand my basic spatial analysis folder, my basic spatial analysis geodatabase, and I'm going to click to drag and drop that Highways US PRJ or projected layer. And I'll turn off my Highways US layer in the map.
Could you have used the projection tool on that Highway US layer from the side?
From inside ArcMap?
Yeah.
Yes. Yep, so the ArcToolbox is available to us in both ArcCatalog and ArcMap. So we could have done that step here in ArcMap as well. So as I zoom out here, notice how long it takes for all of my streets to draw, or all my highways. And as I move around, it's kind of slow to draw. That's because there's something like 1.6 million lines in that data set. Today, I'm only interested in South Carolina. So I only want to analyze highways from South Carolina. Let's clip this highways layer to the state, right? So our area of interest is South Carolina. Our extraction tool, the first one is going to be a clip. So we're going to cut out our highways. What we'll want to do is go up to our geoprocessing menu here at the top. Our basic geoprocessing tools can be accessed from this dialog, from this menu, rather than digging through ArcToolbox. And the second one from the top is the clip tool. So let's click on that. So here we need to specify our input features. This is our cookie dough. And so in this case, that's our Highways US PRJ layer. So if I click this drop-down arrow, I see a list of data sets in the data frame, and I'll click on Highways US PRJ. Our clip feature is going to be the South Carolina border data set. So my clip features drop down, I'll click on South Carolina border. For my output feature class, I'm going to browse, click that folder icon, browse, and I want to go not to my basic spatial analysis geodatabase, but I'm going to save this in the results geodatabase. So for my folder connections, I'll go to basic spatial analysis, double click on results to enter it. And I'm going to call that output highways_SC. And then click save. And once you've set those parameters, go ahead and click OK. I'll leave mine up there a few more seconds. So under the clip features, there's this arrow drop-down list. That was the last one on our list, South Carolina border.
Never mind.
Got it? Okay. So I'll click OK, run our tool. I can close this dialog window here. And if I go to my bookmarks, I see I have a South Carolina bookmark. I can zoom right back. And I'll turn off my projected layer. There are my highways in South Carolina. So I can see none of them extend beyond that border data set. Go back a step.
Sorry, the output feature class, where did you store it?
So I will show it again. From the clip tool, my input features were that Highways US PRJ. My clip features, the South Carolina border. And the output, I went to my basic spatial analysis folder connection. Double click the results geodatabase. We're going to save all our outputs there today. And I call that Highways_SC. Is it working? Kind of. Take a look. All right, so that's clipping. Clipping is pretty easy, right? Our cookie cutter here. The next set of extraction things we want to look at are spatial queries. So our last workshop, we learned how to analyze attributes to identify features that met some attribute query, right? Where say we identified TRI facilities in South Carolina because they had an attribute that said the state they were in. A spatial query is one that's going to use the geographic part of your data set. So it's going to identify and select features based on some spatial relationship, whether it's intersection, adjacency, containment, or proximity. We'll see some examples of all of those. You access it by the Select by Location tool, Select by Graphics, or an interactive select tool where you can use the mouse to define your selection area. So an intersection is going to find features that have some common part with another. Basically, do they overlap one another? You see, here we go. So if I were to select from this line data set, those that intersect my green polygon, it would select this piece in blue, and again, highlighted in our selection color. Adjacency uses features that touch one another or have some boundary in common. So if I were to run an adjacency selection between my red and green polygon data sets, I would select just this red one because it's adjacent to the green and not this smaller one that does not touch or have a boundary. So a containment relationship means that one feature is entirely surrounded by another. So again, if I select from my red features data set, those that are contained by the green, it would be just this piece here. And proximity will use a distance that you specify. So search within a certain radius of that feature and select to select other things. So our Select by Location tool looks somewhat like our attribute query tool, but here we need to specify our inputs. And down here is our method, right? So there's lots of different relationships intersecting within a distance of, contain, touch the boundary of. We can also apply buffers or search radiuses to those. So we can look for things that overlap and an additional distance beyond that overlap. So it's a pretty powerful tool here. So for our spatial query here, we're going to dive into our data a little more. We want to identify some subset of our hurricane shelter facilities. We want to know which ones are in Charleston County and within a half mile of a grocery. And what is the capacity of those shelters? So how many people can they store? Somebody has come to you as their GIS analyst and said, I need the list of any Charleston County shelter within a half mile of a grocery. How many do they hold? You have 5 minutes to tell me, right? Somebody comes on the phone because, you know, hurricanes happen pretty rapidly. So what we're going to do is use these three different feature classes, hurricane shelters, groceries, and counties, and use some spatial queries to identify how many people these specific shelters hold. So let's go back to ArcMap. And we're going to, I'll turn off some of these layers. Turn off my highways layer. And I'm going to zoom to Charleston County. I'll right click my Charleston County layer in the table of contents. Click on zoom to layer. So I can see here in dark green is the border of Charleston County. My shelters are these stars, and here are my groceries. So to select those features, remember we could access our selection tools from the selection menu. We want to do select by location. So our selection method, we can select features from, and it's just the same as our select by attributes. We can add, remove, or select from a current selection as well. But we want to select features from hurricane shelters. So I'll check the box next to hurricane shelters. And we want to first identify those that are within Charleston County. So our source layer in this dropdown, we're going to set to Charleston County. So here for our spatial selection method, we have lots of different options, right? So which one do we want to use? So read through your options and let me know your ideas. What type of those relationships we just saw in the slides do we have between our hurricane shelters in the county?
Is the source layer, is that telling you the area that you're in?
So we're going to select layers that have some relationship, select from this list at the top that have a relationship with our source layer using this method.
So the source layer could be just comparing that.
It's comparing two data sets and their geographic components. So as you look at the list, which one of these do we want to leverage to select these hurricane shelters? Are within, right? We have a containment relationship here. So we want to find those that are within the source layer feature. Some of these work.
There's two of them.
Yeah, we'll first say are within the source layer feature. What you're going to find as you do spatial analysis is there's lots of ways to get to the same place. We could try some of those. We could also intersect. We could do a lot of these, but we'll first start are within the source layer feature and then click apply. And then notice here in my map, all of these hurricane shelters within the county show up in bright blue, right? And I don't see any others showing up in bright blue. So it looks like we searched pretty well. Well, we're not done yet, right? So we also wanted to know those that are within a half mile of a grocery. So here's our select by location dialog. Who has a suggestion for how we can set up another select by location? So under our selection method, we want to select from the currently selected features. All right. So we're going to select from the currently selected features. Our source layer is going to be what? Groceries, yep. So we're going to analyze these two together. And so now what is our spatial selection method? Are within a distance of the source layer feature, which is the third from the top. So here we can type in our box a distance, and we can also specify the unit. So for our unit, let's make sure we select miles, and our distance we'll just type 0.5. So we'll select from the currently selected hurricane shelters, those that are within half a mile of our groceries. Click apply. So how many are currently selected? I hear 2, I hear 3. Where do I go to find out? I'll close my select by location dialog. Now open my attribute table for the hurricane shelters. And I see there are 3 out of however many selected. So what's the total capacity of those? All right, so what's our capacity?
Different. So I had fire station.
So we selected from. Who's got the number? I have the director on the line of some relief agency and they want to know. How many? 1177. How did you solve it?
I noticed on the attribute table the capacity.
Capacity, yep. Or we can right click on the top here, click our statistics, and that will tell us the sum 1177. Right, so remember, you can quickly get a snapshot of any numeric field and there's basic summary statistics. All right.
Is there a way to access these selection filters without having to like stack up lines? Like, is there like a screen that you can see all the parameters of selection you're getting from, or do you go in, do the first selection parameter and go into the second selection parameter? Is there a faster way to do that?
If you set up a model in the geoprocessing tools, if you know all the parameters you want to do, you could automate it, but no. So the short answer is no. All right. So we have our number 1177. So we used our select by location, did a number of spatial queries back to back. Combine those two together to answer this question here. Our next set of tools, we're going to look at overlay. One of the most common, most powerful things you can do in a GIS is look at overlapping relationships. So another way of saying that is determining where geographic data are coincident with one another. So you do this to, say, merge overlapping data sets together, combine them, erase or modify features from data sets together. So overlay tools are very, very common and very powerful. Well, one of the most common ones you'll use is the intersection tool. So an intersection is an awful lot like an AND operator here, where it's going to identify coincident features, but only keep those that are coincident in either data set and then merge them together into an output, right? So it keeps what's common in your input layers. It will merge both the geography and the attribute information into the output. You can do this with points, lines, and polygons. You can intersect any of them together, but it's only going to keep the lowest dimension. Meaning if you intersect polygons and points, your output is going to be points. But here, let's say we have our two layers, the one in this green box with attributes W and Y, and we have layer B, which is our circular Z section. If we intersect this, it's only this semicircular region here that is coincident between the two. So my output would have two features, each of these yellow polygons, but here you see that they retain both their W and Y attributes from layer A and their Z attribute from layer B. So we're merging them all together. So going back to this, this area we looked at before, an intersection example here might be looking at Now we have streets, building footprints and stuff for our city, and we also have a FEMA flood area. So here in our tool, we would add all of those input features at the top, specify the output, and notice that we have a polygon layer, a flood zone, and our streets as our inputs, and our output takes that lowest dimension of geometry. So our output is going to be a line. So our output between the intersection of this blue flood zone area and our streets layer is shown in red. So it's sort of like a clip, but now we're actually going to merge attributes together as well. So each one of these streets has its name and original attributes, but now all of that FEMA flood information. So we're going to look at some storm surge data for South Carolina, right? We know that different categories of storms will push water up onto the shore to different levels based on the category. And we have polygon data for those storm surge zones. And we also have the locations of schools down near Charleston. And we also have some airports. So we want to know which storm surge zone each one of these schools falls into, and our airports as well. So let's go back to ArcMap then. Well, I'll pause. Any questions on overlay or on intersection? No. All right. And I will close my attribute table here. I'm going to click here where it says clear selected features up near the top of the window and clear any active selections. And then I'm going to minimize this extraction data frame over here in my table of contents. Click the minus sign next to that word extraction and expand my overlay data frame. And then I'll right click my overlay data frame. Click on that word overlay and click near the bottom where it says activate. So I'm going to switch from one data frame to another. So this data frame has our world ocean base map layer. It has some counties in it, but also our storm surge zones and our schools. So does anybody need to see that again? Yes? Or you're good? You're good. Okay. All right. So here we have all of our schools. We see our different storm surge zones, green, the lowest category shown, 5 up to a red for 1. And we want to know which one of these zones all of these schools are located within. And we also want to grab that storm surge code. If I open the attribute table for my storm surge zones, they have that as one of the attributes in the table. And I want to append that to my schools layer. So really, I'm going to identify at-risk schools that are located within a storm surge zone. So where do I want to go to find the intersect tool I'm going to use? Yeah, let's try geoprocessing menu at the top. I see it there, intersect. I'll expand my menu a bit here. So our input features, we need to add all those layers that we want to intersect with one another. So I'll click my drop down, select schools, go back to my drop down, click on storm surge zones. And I want to save my output feature class. I can see here in my bar, it will be saved in that results geodatabase. I'll just change the name. It says schools intersect. I'll add schools _ surge intersect. So then I'll click OK, run the tool, and tell me how many schools we have in our resulting data set. Close my results, go back to my bookmark. How many? 226 schools. Yep, so if I open, let's see, 226. So I noticed in my attribute table, we had all this original information about each school. And as I scroll to the right, there's that zone. All right. Close my attribute table here. So now if I wanted to quickly map and show each storm surge zone of these points as a separate color, if I want to show each school as a point with a different color for the storm surge zone it lies within, where do I want to go to do that? Somebody volunteer to show us. This one's easy, right? All right, what is it, Max? Yes, Max is going to show us. Where are we going to go? We want to now symbolize our points using that zone attribute. Where are we? Right here. Yeah. Lots of screens to look at.
So you would go to right-click School Search Intersect.
Yep, right-click on that.
And then you would go to properties, and then you would go to symbology.
Yep. We'll set up the symbology for our layer here.
And you would want to go to categories, and then your value field is
Bottom
zone.
And one more step in there.
Oh, add all values?
Yep, we need to click to add all the values.
And then you could change your color or...
Yeah, so why don't you give it one that goes from green to red, similar to our other data. Yep, looks good. Click apply.
There you
All right, thank you, Max.
Thank
Well done.
What did you get, like, if I have the schools that are even outside the they're still on the map,
You'll need to turn that layer off from the table of contents.
or just the schools?
Yep.
Okay.
I can even make these a little bit larger if I want. All right. There we go. So intersection, we've now merged two data sets. And we've only kept those that overlap, right? So here were our original storm surge zones. Here are our schools that cover the entire state. Our output goes to that lowest geometry, in this example is points, but we're only keeping those features where they overlapped, and our attributes inherit all the attributes from both of the parents, right? So who in their work or research, whatever, would want to intersect data that they already know of? Sammy, what would you want to intersect? How would you want to use it?
Let's see, perhaps I could look for there's some ways I could use it.
There's something. All right. Lewis, do you have an example?
Well, I was thinking, in my job, I would probably want to look for intersection of where groups might want to go to study, since I work on the campus here. And so I would look at where they would come from, so I get a proximity to, you know, where they're located. So I give them the shortest distance to make sure we have a sufficient number of those studies and study areas. So I'd probably do it, look at something like that. That makes sense.
Yeah, would you be taking, say, room or building footprints with different categories and overlapping them like that?
Population, and then looking where the study areas are, and then probably figuring out like a radius from that, and then probably where those intersect.
Oh, okay. So you're actually getting ahead of where we are right now a little bit, using some buffers and radius.
Yeah.
Very cool. So looking at where students are actually located, where the population is,
Yeah.
intersect that with study
That's what I
zones.
want to do with that, and that's taking it.
Yeah, very cool.
I'm noticing with the colors that it shows are actually reversed. With the.
Oh, yep.
So I was wondering how we would fix that.
Yes. Okay. If we double click our layer, it will open the layer properties. It's another shortcut for us. If I go back to the symbology tab, right click on that word symbol, you'll see a menu, and there's a flip symbols option that will take your color ramp and reverse it. And then if I apply, now I see category 1. Yes, thank you. So I had it backwards from before. So our most severe 1 should be red. Thank you. We have 15 after. All right. So our next example of an overlay tool is a union, which is like an OR operation in the spatial sense. An intersection was an and, a union is like an OR. So it's going to merge two data sets, but it's going to combine and output every part of both of these data sets. So similarly to intersection, we're going to output or merge both the geography and the attributes of our inputs. But what's different now is this only works with polygons because we need both this overlapping for this to work properly. So going back to our example with layer A consisting of these regions WX and layer B, see our output of the two, but have all of these component regions within it. And anywhere that there is an overlap in the two layers, the output adopts both of those attributes. Where there's not overlap, you would just have a null value in your table, and it would have its parent attributes, but not from the other data set. So an example of that is if you were working with data that represent two different spatial levels. For instance, you could have neighborhoods here within a city, and then zip codes, which are smaller than a neighborhood, but each neighborhood is some combination of these zip codes. Like you see here, each one of these neighborhoods may have some component of multiple zip codes, and each of these data sets has all of its attributes together. Whoops, sorry. Running that union tool will keep every component polygon within the data set, but now I can see all the portions of the zip codes within each of these neighborhoods, say our, I'm not clear on the names here, but our purple, green, and red zip codes, and each, did I say this backwards? I said zip codes were smaller than neighborhoods. I apologize. Zip codes are larger than neighborhoods in this example. So each zip code covers multiple neighborhoods. And now I can see the portions of each one of these smaller neighborhoods contained within each zip code. And if I identify, use that identify tool, I can see that there is, again, this merging of attributes just like we had in our intersect tool. So what we're going to do is take our county's boundaries, and then we're going to perform a union operation with those storm surge zones. And I have a typo again. That's not good. But we're going to perform this union on the two. So what is our output going to look like? pull up ArcMap here. What would we expect to see if we perform a union between our counties that you see here and those storm surge zones? First, let's just quickly look at our storm surge zone attribute table again. So really all it has here is a zone. If I open my counties attribute table, I see there's a name, state name, a bit of population area. So in my output, I should see both of those anywhere there's overlap. For those counties, say here in the upstate, that don't overlap a storm surge zone, after I perform this union, they would just have a null value for that zone field. Does that make sense? All right, so let's go ahead and perform it. Let's perform our union. Where are we going to go to do this one? Geoprocessing. Yep. Here we go. Is our union tool. So here we'll create a list of our input features. So we'll add our storm surge zones. Click the drop down again and select counties. I'll save my output feature class here in the results geodatabase. And I'm going to call it counties _ surge _ union. And I'm going to uncheck this box that says gaps allowed. And then click OK. And then once that finishes, take a look at the attributes. Did anybody's finish yet?
I'm getting an error message.
What does it say?
It said error executing function table is not there.
Okay. If you close that message, does it take you back to the union tool window?
Yes,
Did you uncheck the box for gaps allowed?
yes.
Did anybody else get this error?
This is hard.
Isn't that just the way?
There's a lot of steps in here. I'm trying to figure it out.
All right, so if I close this now and open the result, there I see that zone, and I also see that for some of them, there is no zone. If I sort ascending, I have zeros where there was no overlap. There was no storm surge zone in those parts of those counties. So what could I now do with this new data set? Any ideas? What if I wanted to get the area of each county that falls within each one of these zones? I could say do a selection first on a county name and then also on a storm surge zone, and I could say sum the area of just those features. Be one example. Check the notes here. Questions? Comments?
Doesn't look anything like that, Davis.
Yours doesn't look anything like that. All right, we'll I'll come take a look. Let's take a break. We'll come back 12 minutes or so. So around 35, 36 after. Feel free to use the restrooms just around the corner. Grab a coffee upstairs. These numbers actually here were anything I might have just hit you on this. But we have the same number of features. Yeah. No, when it first came up, the numbers of these were the same. Technology. Yeah, so that's a local right there. It's not after this meeting. Well, that makes sense.
You know, old image that was done job. As soon as the market goes down.
Right.
I just wanted to learn because I couldn't please understand.
Like when they're talking about you.
And you did have a GIS presentation yesterday. I was like, oh, I know what they're talking about.
Which is good.
Oh, because that lady, yeah, it's all she pretty much did GIS stuff.
Oh, yeah. Yeah, Hirsch.
Did you look at her receipt? I was like, this is a lot of stuff that.
No, I haven't had a chance to look at it. Where's she at?
Drexel?
Oh, really?
It was really good.
Okay.
Genealogy. Genealogy and process. Everything does some part.
Everything else, right?
I don't know why. Maybe once I'll listen to it. Stuff is more adequate to answer that question.
Okay, do these days. A lot of analysis within that just movement stuff, right? Oh, yeah. So they get expected.
Yeah. Well, I guess some people are at it. And you're here, so at those universities, I have similar.
How would one create a data frame? Is it easy to do? Insert data frame. Oh, okay. It's very easy to do.
Like, so when you create the data, if you say if you already have like some data, like a data set or something,
It shows up here, you add data to it, just like any other.
oh, okay, cool.
And then if you want to remove it, you just right click and
So that way, okay, so doing like one step where you're building everything under one thing, if you want to keep it separate, so it's easier to remove one or add one, then that's where the data frame's really good because it's like one. I guess if you're working on some different projects at one time.
yes, and the other thing often I'll cover it in the intro section. So if you're setting up a layout for a map, let's say this is my study area is Charleston County, and I want to have an inset map that shows where that is in the United States or the world, right? I can construct each map independently and then arrange them together onto a page, and each one of these is its own data.
That's good. That's good because I was thinking about because to write my thesis, I'm going to do some maps, and I want to be able where I can put it in like a Word document or something.
Mm-hmm.
So that's good. When it gets to that step, I'm pretty sure I'll be in the office. And
Yeah.
This is like, well, not easier. Don't take as long as
All right. Everybody feeling better? A little more awake?
Like, I feel great.
Let's continue on then. Look at our next set of tools. Proximity tools are those that are going to use the distance between features to either select or identify things or actually quantify a distance or calculate some distances between or around features. So, there's lots and lots of examples of when you would want to know if there's any roads within 500 meters of a stream, right? If I know I'm getting elevated sodium or chlorine ions in my stream, is there a road nearby where they salt it when it freezes, contributing to that contamination? How many schools fall within set distances of a park? What's the distance between the breeding areas for a particular species? Or what is the distance between each feature in a data set and every other feature in another data set? Or what is the least cost path, right? So you can build on proximity to do some sort of modeling and determine what a least cost path might be based on your model criteria. Or, what are the schools within 1.5 kilometers of an earthquake fault zone? So one of those proximity tools is a buffer, and a buffer is a region that is less than or equal to some distance of a particular feature. So they can be around points, it can be buffering around lines or around polygons. And you have a couple different varieties of the types of buffers you can do. A fixed distance is one where you specify what that distance is, and it will identify all those locations from that one set distance. So your output here is always going to be a polygon, but here we buffered a fixed distance around our input polygon. A variable distance may use some attribute information to define how far you want that buffer to be. So if these two lines here, the white one is hard to see, but there's a white and a red, we can say buffer small streams. They have some attributes saying they're small, a specific distance, and a larger buffer for those bigger rivers. So we can have a variable distance. We can also do a nested or multi-ring buffer, which forms concentric circles around your input features. So you can identify zones of various distances all around your input features. So some examples of why you might want to use this: if you want to say locate convenience stores within some set distance of a population or a school, you can buffer around your school 300 feet and then use some sort of overlay analysis to identify or return those features. If you want to say find bus stops within a location of a street, we can buffer around that street 300 feet on either side, and then again do an overlay or some sort of select by location to identify those bus stops. Or if you want to buffer around your parks or around streams, these are other ways we can do it. So different input geometry. Again, the output is always going to be a polygon feature. So another example might be buffering a river excuse me, to look at different environmental conditions to try and determine, say, source inputs to your river. So we're going to look a little bit more at our storm surge zones, and we'll then analyze some bridge data. So we're trying to find at-risk bridges, those bridges at risk of some category of hurricane. So here we want to identify a subset of bridges within 250 meters of a category 3 storm surge. This is our particular area of interest. So first we want to find what are the areas that are within 250 meters of a category 3 storm surge zone, and then use that to identify which bridges are within that area. So let's switch over to ArcMap again to answer this question. Whoops, getting in the wrong spot here. So let's activate our proximity data frame. I'm going to minimize my overlay data frame here in my table of contents. Right click on proximity and then click on activate. So here I have my bridges shown as these dark blue points. I have my storm surge zones. So we want to identify what areas are within 250 meters of those category 3 storm surges. So how many storm surge zones, or how many classes of storm surges do we have in our data? 5. We want to only analyze those that have a storm surge of category 3. So we only want to buffer some subset of our data. How are we going to do it?
Geoprocessing buffer.
We're going to use the geoprocessing and buffer tool, but we only want to buffer the polygons with a storm surge category of 3. So before we even get to the buffer, though, we're going to select by attributes, right? So we're going to run a tabular attribute query to select just those that have some storm surge zone equal to 3, because our geoprocessing tool will run just on that active selection. So I will go to my selection dropdown, select by attributes, and for my layer, it's going to be my storm surge zones. And I'm going to set up that query by double clicking on the word zone. click equals, click on get unique values, double click 3. I want to verify that expression. It says it was successful, so I'll apply it and then click OK to close the window. So now I can go to my geoprocessing menu and open that buffer tool. So I go to geoprocessing. First one in the list is buffer. So here in my help, it shows me what this tool will do. So we need to set our input features. So our input features would be our storm surge zones. And our output feature class will save in this results geodatabase. But I'll change the name of it and call it category_3_buffer. And we need to specify a distance. So here, our linear unit, we can specify whatever we like. I'll leave it as meters, but we want to search within 250 meters. And here I want to go to my dissolve type. And I'm going to select all for my dissolve type. And I'm trying to get the tool help. I'm trying to pull up the diagram here. So the dissolve type, if you select none, it's going to buffer each feature and then keep one buffer for each one of those input features. So if there's 100 points in our data set, it will create 100 polygons. If you specify dissolve type all, any overlapping buffer zones are going to be merged into one polygon in the output. So you can see here around the points, these two individual buffers would be joined. This that doesn't overlap remains on its own. So we just want to keep, we're not interested in every single area individually, we're interested in the areas overall. So we will dissolve all. And then you can click OK. And run the tool. So the dissolving adds a little bit of processing time to it because it has to find overlapping features and merge them all together. So we did the first part of answering our question. We have identified areas within 250 meters of that Category 3 storm surge. Now we want to find the bridges that are within those zones. So how can we identify those bridges? What geoprocessing tools or other options are available to us?
Or you can use the intersect tool.
I just heard use the intersect tool and I heard select by location. Both would work.
We're getting an error.
Getting an error.
It's running out of memory. Out of memory, failed to execute buffer.
Anybody else want to Okay. Well, what would be the difference between those two methods? If we do an intersection, what would be the output of that operation? It'll give us the points.
It would give us the lowest edge output.
Yep.
Because the bridges are.
Right, so but it's going to return those in a new feature class. Right, so if we're interested in creating a subset of those data where they overlap and saving that as a new feature class, the intersection tool is what we want. If we do select by location, we can just select from that existing data set and identify that subset of features. We're not going to create a new data set along the way. So there are two ways of getting to the same place. They do it slightly differently. And so depending on what you want in your output, you may prefer one method over the other. So how many, let's take a vote. How many want to intersect? How many want to select by location? Select by location. All right, you guys have it. So where do I want to go to do that? Select by location. So selection tools, menu, select by location. And what are my parameters going to be? We're going to select features from our bridges layer. Our source layer is going to be that category 3 buffer. And we can specify are within a distance, right? And we'll change our units to meters. Oh, sorry. We know our distance here, but we can say contain the source layer feature and turn off apply a search distance. So I'll open my bridges attribute table.
Which one did you say to choose?
Are you on select by location?
Yes. And
So-
I have the bridges and I have the storm search,
And our category 3 buffer, and I'm going to say contain the source layer feature and turn off apply a search distance. So there are 9,600 bridges in my data set. When I click apply, let me try intersect the source layer feature. There we go. How many bridges are within our search list here? 514 is what I get.
My ArcMap basically shows up as and it shut down some of those. So kind of click and drag the basic spatial analysis database or the ArcMap. Because if I can get this data back off, I can. All right.
And then you can activate that data.
Yeah, that's.
All right, so there was our buffers. Another set of proximity tools we have are the point distance tools. Let's say you have 2 point data sets and you want to know the distance between every point in one data set and every point in the other. The point distance tool will append that information out to a table and tell you that distance. The near tool is a more generalized one. And so what it's going to do is look at both data sets and tell you what is the closest feature from one data set to another, and then also give you the distance between the two. So here it would output that this polygon is the same, or I should say Lake 1 here is the nearest feature to both input points 1 and 2, and it outputs that distance between them. There's also a K nearest table tool. If you want to know, say, the first 5 nearest features, or 10, or whatever K is, that's available to us. So our near exercise, we're going to output to a table how far each of our hurricane relief centers was from a major highway. And then we also want to know what are the minimum and maximum distances in that output data set. So this time we're going to have to actually open the ArcToolbox and dig around to find the near tool. So let's switch back to ArcMap. I'm going to close this attribute table here. I'm going to click where it says clear selected features. And I'm going to turn off my bridges, my category 3 buffer, and my storm surge zones. I'm going to turn on my hurricane shelters layer, but now I need to drag and drop from our catalog that highways SC data set that we created before. So I'll go to my results geodatabase. I see that highways SC feature class. I'll drag and drop that into the map. And I'll also go to my SC bookmark. So I can see here are all the hurricane shelters all over the state, and here are the highways. So let's figure out how far it is between all of these hurricane shelters and the nearest highway. This will give us some idea if they're accessible by road or not. So we're going to go into the ArcToolbox. So I'll click my ArcToolbox button up here, or I can also open ArcToolbox here on the side of the screen. Once I click it, it may take a second for it to open. Let me check my notes for where it is. The analysis tools, proximity, near. Oh, there it went. Here's my ArcToolbox. So we want to go to the analysis toolbox here near the top and expand that one. And here we have our proximity tools set and expand that. And then we want to double click on that near tool. So for this tool, we're going to set our inputs as the hurricane shelters. And our near features will be the highways SC layer. And then we can accept all the other defaults and click OK and run that tool. Uh-oh. Not get exclusive schema lock either being edited or in use by another application. Let me close our catalog. I'll go to my Arc catalog program and close it. Go back to my near tool. Fingers crossed. Nope. Did it work for anybody?
Yeah, I didn't get it.
So it's working for some people and not others. Great. What did I do here?
Worked when I closed our catalog.
Okay. I'm going to try that again. Go back to my ArcToolbox, open the tool set, set my input as hurricane shelters. Highways SC is my near features. So how many got it to work? How many?
I can't see the table.
I didn't get an error message, but it's, I mean, I don't, it doesn't seem to have selected any.
Yeah.
Something either.
So if you open the hurricane shelters attribute table, you should have some additional attributes show up on near FID and near distance fields. But I'm not clear why mine's not working and others aren't. Oops. ArcMap seems to be going very slowly for me. So I'm going to close ArcMap and open it again. So for those that had it work, how far on average is one of our hurricane shelters from a major highway?
Meters.
How would you find out?
Near distance. Oh.
How would you find out if it was meters? They'll be in the units of the coordinate system. So you're correct, it is meters. So I guess heard 611 meters. Anybody else confirm or deny? Yeah. And where did you go to find it out?
Attributes table, and then near distance, and then statistics.
Right, so from the attribute table, we can right click that near distance field, click statistics, and view that information. I have Brian remotely confirmed 611.06 meters on average. Let's see. Jeffrey, if you have to create a shapefile of layers for each of these. Sorry, I didn't see that one. I'm not clear what that question is referring to. Let's see, if I try and open ArcToolbox again, is it going to let me run this tool or not? Nothing ever goes wrong when you're in ArcGIS, right? Even when you carefully select data and run through all these exercises ahead of time, nothing ever goes wrong when you're standing in front of a full classroom. Let's try this again. Hurricane shelters near our highways. Sometimes you just need to close ArcMap and open it again. So now if I open my hurricane shelters attribute table, here's that near FID. So what that FID is, that's that feature ID from my highways SC layer. So if I open that attribute table, each one of these has, here it's actually an object ID. So what that's telling me is that for this particular hurricane shelter, if I zoom to it, this one here, it's telling me that it's nearest to the highway with FID 1507. And if I use my identify tool and click on this line segment, there's that object ID 1507. So if you need to know in a more comprehensive way information about, say, this particular road, that gives you a link through that feature ID to find more information about that particular feature. And then our near distance is shown here, and these are in the units of our coordinate system, which is that South Carolina state plane system with a linear unit of meters. So if I right click and grab my statistics for it, whoops, I have 1 point selected. right click, do my statistics, I see the mean of all those is 611. Right. Questions?
I'm sorry, what were you doing with selecting the lines?
So I was just pointing out here in this near FID tool, or this near FID column, that for this particular point, for this shelter, what it gives me in the table is the object or feature ID, the OID or FID, of the nearest feature from the highways data set layer. And so I use the identify tool to click on it. I would expect to see that that is the output. And I see that has the object ID 1507, which means that that is the feature nearest to that hurricane shelter. So if I wanted to learn more information about that street or whatever it is in that nearest data set, this gives me a link between the two, and I can look them up. Does that make sense? Any other questions? Just take a look at something? All right.
Sounds good.
If you continually see it, you generally have to close it.
Yeah, well, so do mine. Fairness, and just went blank.
All right. Let's continue on to our last set of tools here. In our last workshop, we joined tables together by linking up some code or key field between the two to append those attributes in the table. We can also do that same thing now through a spatial join. So rather than matching features in a table, we can use these relationships of intersection or containment or proximity to append attributes from one data set to another. So the same relationships or cardinality between the two applies. So whether you can join directly attributes from one feature to another, or whether you have to summarize features from one data set to another, depend on that cardinality. So some examples of what that looks like are here. If we have on the first row containment relationships. If we have a many-to-one operation, we're going to join features. So the example would be our animal locations are our destination, and our habitat is the source. So if we join spatially the habitat back to these animals, each one of the animals will adopt the habitat attribute to it. If we do the opposite, a one-to-many relationship where we're going to join animal locations to the habitats, we need to summarize those animals in some way, right? Because it's not clear which one of these animal attributes should be joined back to that habitat. Does that make sense? Nice. So another example would be looking at a distance relationship here. A many-to-one would be if we're going to append the stream information to its nearest septic tank. So each septic tank would adopt or have attributes joined to it from the nearest feature or stream feature. The opposite would be if we try to join septic tanks to streams, we need to summarize those septic tank data so that this stream will only have one value joined to it. So there's all sorts of examples that you can look through that show how you can join points to points, lines to points, polygons to points, and all the reverses of them. An example in practice would be, let's say I have schools and I just want to append the attribute information of the county they're located in. So we're joining the county information to our schools data set. That's a many-to-one. And so you access this from the same menu. We right-click on it, say joins and relates, and select join. But now we're going to join data based on their spatial location. And you can see you now have spatial options rather than linking up a table. So you can give each point information from the polygon it falls inside, that containment, or is nearest to it. One difference here is that the result is always going to be a new data set. Before, when we joined tables, that was dynamic. It only lived in ArcMap. Here, we're going to create a new shapefile or feature class in the geodatabase that has the two joined together. The opposite example would be joining schools to the counties, right? So what we need to do is summarize, say, the number of schools, the sum of schools within each of these counties. And so when you do that operation, we have to summarize, and you're given options for how you want to summarize that information. Take an average, take a minimum, maximum, or the sum. And again, we're going to create a new data set. An example now of proximity rather than containment is if we're going to join schools and parks to one another. So here we could take each one of these schools and join it with the park that is closest to it. And that will output our school information to tell us the name of each park that's closest to it in its attribute table. Here we have an example of overlay for a spatial join. But I'm going to skip ahead to our exercise here. So we have information about each airport, such as their location, and we want to append the storm surge category that each one of these airports falls within. So we're going to do a spatial join for that operation. So let's switch back to ArcMap. I'll close my attribute table here, minimize my proximity data frame over here in the table of contents, right-click my spatial join data frame, and then click Activate. So if I expand that data frame, I say here are my airports. They're symbolized by how many people go through them every year. And here are my storm surge zones. So if I open my airports attribute table, my goal here is to add that zone attribute by joining that information from my storm surges. So where did we need to go to join features or tables or any sorts of join? Right-click on the layer, right? So we can right-click on our airports layer because we're going to join that storm surge category to it. So right-click my airports, click on Joins and Relates, select Join. And here at the top it says, what do you want to join? We're going to select not join attributes, but join data from another layer based on spatial location. And so we'll choose the layer to join. We only have one option, our storm surge zones. And we're going to give each point all the attributes of the polygon that it falls inside, this first option.
It's like an actor. I'm just getting a blue screen and not the.
I got that.
I do a right click.
I did.
I did it first, but I never stuck it.
Yeah, I got the text.
We'll try it and see if it'll.
I just let it close my mouth.
Looks like the tool will hopefully still run. Let's save our output in our results geodatabase, and we'll call it airport underscore storm underscore surge. And then click OK. So I have a new layer shown up here, this airport storm surge. I'll right click it, open the attribute table. And here I see that zone. So unlike an intersection, I haven't discarded any data. Right, I've kept every single one of these features, all 58 of my airports, and anywhere that there was no overlap, I just populate null values. But if I sort these, say descending, I see there are 2 airports. Beaufort Marine Corps Air Station and the Grand Strand Airport are within Category 5 hurricane zones, all the way down to Category 2 storms for the Charleston Executive and Beaufort County airports. So hopefully they're prepared for some big storms. That's a spatial join. So we've appended these attributes from one data set to another. Questions?
So if I have the storm surge and check, it's not showing up on the map. It's not connecting or something. See the airport. It's check. Because it's restarted. Just had to restart it.
Questions from anyone? Comments? Everybody feel pretty good about spatial analysis so far? Then you have homework. So here is our proud Clemson tiger bird shown here. This thing is very rare, it's skittish, and some biologists only started seeing it after we won the national championships year before last. They decided it was time to come home. Our tiger bird is a very particular creature, though it only nests in evergreen forest near water sources for its chicks that it lays, and it doesn't like loud noises. It's scared easily, so it's usually found far away from roads. So some biologists working in the Saluda River watershed or Saluda River Basin want a map of the potential habitat. So they want to know, where might this thing be found so that they can send out their teams to go try to, say, tag them or at least find where they're located so they can study them more. So within our, I'll switch back to ArcMap, this spatial analysis problem geodatabase has a few different data sets within it. This NLCD upstate poly, wish I hadn't closed Arc Catalog. I'll open it again so we can take a look at the data. But what the biologists want is a map as an output that shows the locations or boundaries that meet all these criteria. So they want to know exactly where to send their teams. So the map they're looking for shows just these zones that are at least 200 meters from noisy roads and within 50 meters of streams, and are also evergreen forest types. So we have 4 different data sets. We have land cover that tells us information about what's present on each parcel of land. We have a watershed data set, or this boundary of the Saluda Basin. We're only interested in one particular river basin. And we have lines representing streams, and we have lines representing roads. So if I go to Arc Catalog here and preview these data, you can see our NLCD upstate polygon. It takes a very, very long time to load. But if I switch my preview to the table, I see there's different codes, and here's the land cover, right? So it could be mixed forest, developed, open space, evergreen, mixed, probably a few other categories in there. My Saluda Basin boundary. And then I have roads and streams within the Saluda Basin. So your mission in the remaining 30 minutes is to create a map of these locations. So what I want you to do is entirely optional, but here's a test for you. Try and see if you can figure out all of these locations and put that into a nicely formatted map. And you can feel free to help each other. I'm here to help you answer questions. This is a real opportunity for you to test what you've been learning the past few weeks and see how you do with some sort of problem. That's fairly realistic, I think. I made it up, of course, but this is a very simple and common type of analysis you might want to do. So 1, 2, 3, go. Again, totally optional here. Before you leave today, if you could fill out your feedback at this link. And next week's workshop will continue on in our spatial analysis. We're going to switch over from vector data to raster data and do things like raster overlay, actually learn how to process elevation data, interpolate values to estimate values between features, and a couple of other things. So you're free to leave if you like, or stay and work, and you can ask each other and meet questions. Have fun. Did you? I think I put a link in the chat, but if you prefer to just.
So, what are your toolbox? Not the power, like layers. So,
How do you bring back which one?
no, it's the layout. Something's gone.
Oh, go to Windows and select table of contents.
You're talking about creating a new shapefile, like. So when we did this storm surge, this new analysis, the airport surge, we would just export. We just go to properties view. How would you?
So how would you
create that new shapefile?
empty one?
Yeah. But what would you say when you join something?
When you do a spatial join, the output is always a new shapefile or feature class. which created that airport
So, like-
surge.
So like when we created highways at sea, like how do we do that? How would you create?
That was the output of that clip tool. Right, remember we clipped our projected US highways and then used our South Carolina clipping, and so the output was a new featured class saved in the results to you. So we still have our original highways US and the projected one, but now we've created a new one that only contains.
Okay, so if I were to create another one, how would I do that? Amazing.
It depends on what you're trying to do, I guess. If you wanted to clip another data set.
So if I want to clip, I don't know how to explain.
Like if you were looking for all the airports just in South Carolina, you can click this airports data set. South Carolina border.
So just drop it.
Or you just trying to add stuff to the map.
I'm just trying to figure it
If you want to add data to the map, we can drag and drop it from.
out. Right. So I can just drop it, right? Okay. So then I want to create a shape. I'm just trying to figure out how to create a shape.
Yeah. So if you right click either on the folder or geodatabase. Here, and then you
Oh, that's it.
and then feature class.
Oh, that's good.
How many started it? Shut everything down.
I'm trying to project, it's not all from the same data set.
Yeah.
So I'm trying to do that, but.
How about a race? Who can make a map the fastest? See if you can do it faster than I can. Who's already got it? So the way I would start this is I would start a new map document. Start a new blank map. And then think about the problem. So who has suggestions? How would you isolate or find just these areas? What's your geoprocessing workflow going to be? What tools or operations do we have? What order do we want to apply them? There's a lot of ways you can do it. There are a lot of ways, yeah. So I think we've seen there's multiple ways to get to the same place. I started by creating a new layer by selecting just the evergreen layer cover. And I click that in solid basin evergreen. That's a good start. So if we select just from our land cover, those that are evergreen, and then clip that with our Saluda River Basin boundary, and that will give us a new data set that's just evergreen forest in that basin, right? Smaller than you work with. Because that NLCD land cover is huge. Do I get this open? Yep. What else would you do? Go ahead and clip the roads, the basin boundary too. Yeah, we can clip those roads to the basin boundary. And make a buffer. Buffer which one? Around the streams. do a buffer on our streams. Mhm.
Make a buffer, thinking out loud.
I was gonna say, the thing is, the saluted basin boundary is in a geographic coordinate, and that's objective. So the first thing I did was to go to ArcToolbox and
Do a projection.
projections.
Excellent. Yes. Excellent. So I have my blank map. All right. So if we look at our coordinate systems here, our NLCD are in UTM zone 17 north, which is a projected data set or coordinate system. My Saluda Basin boundary, geographic coordinates, my roads, UTM, and my streams, also UTM. Excellent. So I can search for the project tool. Input my Saluda Basin boundary. Specify my output in projected coordinate systems, UTM, NAD 1983, UTM zone 17 north. Click OK. Save my output. All right. Select just the average. It will grab just that. So you could click it and select export to data sets along the way.
This one. And now.
And control volume, type this.
Like,
Make sure you.
we're not doing wrong, like, it's everything. So, we want to change this, we go to check for this, right?
I wonder too, for street like this. Yeah. How much do you think it would cost to get a computer that just does it like that with no downtime?
I don't know. Well, as much as you want to spend.
Yeah.
What's really interesting, you're gonna appreciate vector calculations like this, where you're looking at overlapping features, is very computationally intensive.
And that's all.
Like what a computer is designed to do is if you give it rasters where it just looks at one cell and another and it goes really fast through all those calculations. Here it needs to actually analyze a lot of different features and continue it. It's much more sophisticated computationally to work with things. So, I mean, you have some benefit to getting the also I log out a lot of computers.
So my MacBook probably would have trouble, or it doesn't even run on Mac. You need emulating software.
Yeah, you boot camp. Log out.
Is this the intro to spatial analysis on Quest or on the survey?
Yes. It doesn't say basic, it says intro to. Uh-oh. Change that. Thank you. See you later. See you, Anthony. No, that's what this is here for. Test it out. Rather than following steps in a tutorial, make it open-ended. So the way I would start is pulling the data piece by piece into the map. So first start with that projected Saluda Basin boundary. Yep. And we have our NLCD upstate,
Right,
which has our evergreen forests. We have our streams layer, and then we also have roads. And so I'm really only interested in the Saluda Basin. I'm going to clip, say, my roads to the Saluda Basin boundary.
You don't need to like add a base map or anything.
You don't need to. I mean, when it comes time to actually put display the map, like in a layout, you might want to add the base map. But for the analysis, it's really just going to slow it down.
Is there just like a button for adding base map?
There is. Got it? Do you have it put together into a layout view in a map? I want to see a finished map. Yep.